Okay, here's the unit. Let's here's the sensor. It's made with the touch sensor chip on the back with a connector, and that's almost it. And here the sensors are on this side, so it lies flat against a piece of glass or plastic or even behind a thin piece of wood. Now, let's here's the software. Let's just load it in there. Okay, there it is. Uploading. Done uploading. Got it. Okay, so let's take a look at this in action. Launch the monitor program here. And now we can see what happens when we touch each of the sensors. Except the last one is programmed as what they call a power button. So it won't activate from a casual touch. This one needs a 1-second push, and then it outputs its value. Alright, now let's get into how the program works. Here is the actual core routine that reads this chip. Although there's a lot going on in the chip, just 2 of the registers are needed to do this access. Now here's these are some functions I wrote. One is touch switch write, which gives a register number and a value, and touch switch read, which gives a register number and returns a value. These all access the I2C interface, which I also wrote for reasons I'll explain later. So accessing and reading the data, the chip also puts out a hardware line. So it's very easy to read a hardware line, and this routine returns a 0 if it's not activated. Writing to register 0 clears this line, and then you would think it would clear this data. It turns out if you clear the line after you read the data, you get the wrong data, which was very confusing until I realized at this point in time, looking at this in real time, when this is active, your finger is still on the sensor. So it clears all the sensors, reads your finger, and then returns by scanning for that bit number, adding 1 to make it 1 through 8 for sensors and 0 for none touched. Alright, now that I'm going to edit some of this out here, that's for sure. My hemming and hawing around, boy, that's the thing you like about it. So there are other ports to access, other registers in the chip. When I do the setup on this, I just do a reset to ports to register 0. That clears the interrupt bit. This one sets thresholds. 70 is close to the top. It turns out through a 1/16 inch of glass that was overly sensitive, it was actually reading before my finger even touched the glass. So I raised the threshold, and there's a sensitivity control on this register, and I fiddled some bits here and found a better register. Here is the auto repeat. I've got none of the bits set to auto repeat, so this register 28 hex, they're all zeros, so I'm not doing this one here lets you choose between getting an interrupt on both touch and release, or just touch, and I want to just touch, be it simple. And I took the 7 button 0 through 7. 7 is what I'm calling button 8. This has got the power on feature, and this sets the power on delay. I've got it to 1.1 seconds, so you have to hold it down for that long. Now the thing ran without any of this. Okay, as they say right out of the box, it would run and just register 0 to clear the interrupt, and register 3 which simply stores the data. Now if we look at the documentation on this, it's pretty well documented. Here's register 0, address 0, and the bit 0 is the INT pin. This is also the hardware line that comes out so you can read it conveniently without having to do an I2C read of the chip. This is set to 1 and the external line is pulled low. At the same time you clear it, you set up the gain. I've got this set to the default, which is minimum. This was overly sensitive. The other register, on register 2, whatever these were, seemed to go. Mostly this is disabling some features I haven't even tried yet. I left it alone. Number 3, each bit shows one of the sensors. So when you read bit 3, register 3, you'll get all of those. Now I could get into detail here on how all of the others work. Each one shows counts. It's actually an oscillator running, and when you touch it, your body capacitance changes the oscillator frequency. But let's get back into the program here. Now, I mentioned that I wrote my own I2C routines, and here they are, by bit banging. Well, why did I write the routines? Aren't those available in some library? Well, I'm sure they are, and I don't like the libraries because I'm used to writing assembler, and I like to control how things work. As it turns out, this thing only works because I wrote my own routines. If you notice the cable here, this ribbon cable, there's far too much crosstalk and capacitance to work on that distance. So running full tilt at 400 kilohertz clock, you could run if the chip was right in here. But having a delay, and how I do the delay is these little X calls here, salted through here between every pair of operations. What they do is they slow the things down. It's just a little routine after them here. Delay microseconds. Now, I've got it set at 5, which runs about 100 kilohertz access, which will do that long ribbon cable. And also shows up better on the scope. These routines, if they're running full tilt, and you're running the other program I use to get into the chip, they wind up getting spaced out away from each other on a scope pattern, and I originally did that. But that's for another video here while I show you how the prober program works that lets you go into chips and find your way around from a console. So that's it here. If there anything else, here's the basic I2C functions: the start bit, the stop, the byte read and write, and the delay. And on top of those, I created touch switch write, which does the I2C sequence to write a byte to a register, and touch switch read, which returns a byte after reading a register. Now, of course, this makes all the other stuff a lot easier. And then, of course, the main routine here. That main routine is simply called by a loop, calls the button read routine. If it's 0, it loops back here. If not, it does this output of the data. You'll notice print X is not built into the Arduino. Unfortunately, Arduino does not do the old print F, which if you're a C programmer, you find is very handy for doing formatted output of your data. But it does have sprintf for some reason, which will do a formatted print to an array. So I created this. You give it the format string and the data. It prints it into array, and then serial prints out the array, which is a ASCII string. So effectively, now the thing about this, it does not take a variable list of arguments. It only takes one. But it's awful handy. So it does a new line here, says sensor, and does a hexadecimal output with 2 bytes with always a leading 0. And then outputs the data. Well, that's it. Okay. The code was written for a nano, and to make it generalized, I redefined things like the port, the input port, the port direction. These can be changed to run in another chip because this is supposed to be a general driver routine. Also, these lines can be defined as anything on the port that you want. That you can define the clock, the data, and this interrupt one. Okay, and that's about a wrap. Hope you liked it. I may add some extra doodah stuff when I do this in post-editing. Other than that, have a nice day.